Hi everybody, Stephen here. This is part 5 of our vSphere performance series. And in this one, we're going to talk about storage performance. So we're going to take a look at what counters we need to watch for, what do they mean, what's good, what's bad. We'll do a bit of a storage review, and that's it. So stick around, and we'll see you in a bit. Bye now. Thanks for sticking around, everybody. So what we're going to do in this piece, this will be a lecture demo portion, so it's probably be a little long, this video, but anyways, we're going to talk about storage. Now, storage can be a very fun thing when it comes to doing performance. Like when I talk about CPU or I talk about memory, for the most part, a CPU is a CPU, whether it's in a server A or server B. It doesn't really matter. Same thing with memory. It's memory, right? But storage is a different beast altogether. Why? Because it could be vastly different from one environment to another, okay? And it can be completely, and even the same storage subsystem can be completely configured differently from one environment to another, and it would behave differently. So storage can be a bit of a bear to figure out, especially from performance. Most performance issues that I've run into were storage related, right? Especially in the old days. Today, the technology has improved quite a bit. NVMe, solid state drives, really fast stuff. But again, we still have that potential to have problems. Now, I normally like to throw this out at this point. If this is the kind of stuff that you like, please support the channel by subscribing to it. Totally free. Just click that subscribe button. Also, share these links among your friends because that helps out with the YouTube algorithms. Another way to support the channel is I got super thanks enabled, but that's totally up to you. Now, what we're going to do, let's jump into it. Let me get my iPad going here. All right. So what I'm going to do in this part here is I'm going to do a bit of a storage review. Now, if you don't want to sit around for that, I understand. Maybe you're a storage guru. Totally cool. If you want to skip the storage review and jump to what's important and the counters, jump to this timestamp, wherever I'm going to put that up here, okay? So you'll jump to that timestamp. All right, for those of you that are sticking around for that, let's continue on. So when we talk about storage in a vSphere environment, let me actually get rid of my, let's do iPad only. There we go. When we talk about storage in a vSphere environment, you typically have a couple of different technologies that it supports. It supports local disk. Now, first of all this stuff has to be on the hardware compatibility list in a production environment, okay, folks? In a lab environment, I don't care what you do, right? But we have, choices of fiber channel. We have choices of fiber channel over Ethernet. We have local disks that are local to that physical server. We have iSCSI technology. We have SAS and SATA. I didn't put SATA in there, right? SAS is serial attached SCSI. SATA is like your serial IDE type drives, right? And you have NFS type storage as well. So there's different technologies, and they all have different capabilities. So these are the different type of storage models that we have. When we talk about the software-defined storage, well, if you've watched my vSAN videos, if you haven't watched them, okay, vSAN is another type of technology for storage. If you can't, let's say, have a storage area network, which I'll talk about in a minute. We also have storage that supports this thing called vVols, or virtual volumes. I'm going to say it's relatively new, but it's been around for over 10 years, okay? But from a storage perspective, if I look at storage timelines, it's relatively new from a storage perspective, okay? And vVols is almost, I don't want to say it's almost the same thing as vSAN, but it actually treats your VM as an object, okay? So it does have some advanced capabilities that you can do there. I'm not sure how many storage subsystems supports vVols today. I haven't looked at it. Look at the hardware compatibility list. I know it took quite a few years. When it was first announced, I think it was vSphere 6, if I remember correctly, about 10 years ago. When vVols first came out, I think there was 1 or 2 storage subsystems that supported it, and that stayed like that for quite a few years, and then more and more added. I think Dell supports it now as well. But anyways, you can check that out. I'm not going to talk about vVols in this, but again, just keep in the back of your mind the technology does exist. When we talk about the technology, you got a little chart here saying, okay, for fiber channel, we use we got the SCSI protocol inside fiber channel. The transfer, it's a block access. So if you look at fiber channel over Ethernet or iSCSI, these are all block access. It means you're formatting the disk, usually with the VMware file system. Okay, the interface, it'll be a fiber channel host bus adapter. For fiber channel over Ethernet, it would be, again, a hardware fiber channel over Ethernet adapter, or we can actually do like a software fiber channel over Ethernet, but apparently that's going to be deprecated, right? iSCSI, we can, again, I'll talk a little bit more about these, and I did my, if you watch my demo on setting up iSCSI, that might help you as well. But iSCSI, you can have an iSCSI physical adapter, a host bus adapter. You can have a NIC that's also kind of enabled for iSCSI, or you could use what's called a software iSCSI. I actually demoed that in one of my videos. And NAS, network attached storage, is basically accessing storage using a file transfer protocol or the network file system, right? And that's using a network adapter, right? So they all have their pluses and minuses. You know, like fiber channel, usually really good on performance. Same thing with the iSCSI. I'm more of a fiber channel guy, to be honest with you. I've been playing with it for a very long time. And then you get all the way down to NAS, network attached storage, right? Again, that's usually more a cost-effective model type of thing. So it's going to vary depending on what you have, what your budget is, or whatnot. Let's get my camera going back here. All right, so this slide, I kind of like this. This is showing me, here's my ESXi host over here. That's what the box is, right? And then it's showing me basically how I can connect to different storage. So here you see we have fiber channel. So you'll have a physical fiber channel adapter. Here I'm showing you a picture of one. This is an older QLogic card. It doesn't really matter. So you got a fiber channel adapter that's inside your server, and it's going to load the device driver for it. Okay, so it has to be supported by ESXi. Then you're going to be connected to a SAN, a storage area network, generally. And then you're going to connect down to some kind of storage subsystem that's connected using fiber channel, okay? And then you'll have disks in there and LUNs that you'll access. Great. iSCSI, there's a couple of different ways we could do iSCSI, right? You can actually have an adapter, a host bus adapter, right here, a host bus adapter, and I'm showing you a picture of one right here. It looks like a network card, right? It looks exactly like a network card, except for it's got a chip on there. And what we're doing is we're taking the SCSI protocol and then jamming it inside an IP packet. Okay. Then we're going to, so we encapsulate that inside the IP packet, then we decapsulate it at the other end. So we're running SCSI over an IP network. Okay. And who does all that encapsulation and decapsulation of that? With a hardware adapter, with the iSCSI host bus adapter, the chip on the card does that. So it's done in hardware. But if you can't afford that card, you can actually use a regular network card that's supported by vSphere and load up the software iSCSI. Okay? And at that point, your CPU on your host, the CPU is going to be doing all that encap and decap. There are some cards that they call it, it's kind of a hybrid between the two, some NIC cards, where it can maybe do some of that work as well. So there's kind of a hybrid solution in between the two, but I like to just show the distinction between one or the other. So one card is dedicated to doing that. The CPU has nothing to do with the other one. Your CPU is doing that. Obviously, that's going to potentially impact performance, right? So again, iSCSI is another way we can connect. You can also have local disk. I didn't show you that. You can have local disk as well. Generally, with your iSCSI and your fiber channel, you're going to be formatting your volumes over here with the VMware file system. So I actually demoed this in my vSphere storage video if you want to watch that. The last one, this is network attached storage. So basically, one way of looking at this network attached storage is you gotta, like, for example, most of you are probably quite familiar with Windows. So I can go into Windows and I can share out a folder and somebody can attach to that folder and then we can copy files back and forth type of thing, right? So same kind of, this is sort of how network attached storage works. In Linux, we use the network file system. So if I had a Linux server, I could share out a folder or a subdirectory or whatever, or LUN, sorry, I shouldn't have said LUN. Anyways, I can share out a folder in Linux using the NFS file system, right? So you can think of this NAS as a Linux box sharing out a folder. And what's that folder? That folder is basically the content, sorry, the folder is basically the contents of that drive that you're sharing out. So you have to format this with a with the file system over here. So whatever that appliance is, it's going to format it with its file system, and then it shares it out. So that's going over Ethernet. So it's kind of a very affordable solution. Is it the most fastest? No, but it's okay. Again, you know, depending on your environment and what your needs are. So there's a lot of options when it comes to storage when we talk about vSphere. Now, some of you may not be familiar with storage area networks are. I'm just going to give you a real quick thing on this. I'll do a separate video on storage area networks and zonings and stuff. If you're interested in that, leave comments below and I'll put that together. So here is an example of a storage subsystem. I just grabbed some images off the internet, right? I was going to throw in some of my older IBM stuff, but I figured, whatever. So this is actually, I got one from Lenovo. I just found these. I'm not endorsing Lenovo, or I'm not getting sponsored or nothing. These are some of the clean images I could find, right? Generally, you'll have your storage subsystem, and it's got a whole bunch of hard drives, right? So we see over here, there's a whole bunch of hard drives, potentially up to 24 drives. That's the front view. When you look at the back of your storage subsystem, you'll generally have power supplies. In this case, we see 2 power supplies. That makes sense for redundancy, okay? Then you'll have these things called, what I call them, controllers, right? You'll notice that there's 2 of them. One here and another here. Why do we have 2? You might have 1, again, depending on your environment, but most of the times you'll see at least 2, right? And we have 2 of them. And you can call these, now depending on your vendor, if it's a Dell, HP, whoever, right? Lenovo, they may call these something different. They may call them controllers, they may call them blades, may call them targets, whatever the case may be. When I was teaching storage at IBM, we call these things the controllers, right? They're basically, it's a computer. It's got memory, which is the cache. It's got a processor. These controllers are in charge of doing all your RAID functionality for you, right? And other stuff as well, right? So this is basically the brains behind your storage subsystem. We got 2 of them here because, well, redundancy and performance. That kind of makes sense. Now, if you look closely at these controllers, again, depending on your vendor, you'll generally have some kind of management ports. Let's clear all this stuff. You may have ports for management. Okay. You may have ports for expansion. I'll say drive expansion. And you may have ports for your hosts to connect to. And these ports here could be fiber channel, iSCSI, whatever, depending on the technology. Okay. So these ports could be, let's say, a fiber channel port, an Ethernet port for fiber channel, for iSCSI. Sorry. So it really depends on the solution you're buying. Okay. So let's go down. So this is basically maybe, you know, a sample type one that you might see in an environment, and most of them are configured like they'll have some commonalities here, like I was just pointing out. Now, I mentioned you may have some expansion because I only get 24 drives in here. Suppose if I want more, right? Well, I could add on more storage, right? So you'll usually have, like, they call them shelves. So you'll usually have an enclosure that's just, it's kind of like just a dumb enclosure, and it's just got a bunch of drives. So if you look at the front of this thing, it's the same thing. It's got a whole bunch of drives there. But when you look at the back, it's different. You still got power supplies. Again, 2 for redundancy. But then you don't, these are not smart controllers. They're basically just interfaces for me to connect to the drives. Okay? And you daisy chain these things together, and I'll show you an example of that. So here, again, I'm showing you, here's maybe my controller on top. That's that first one I showed you. So it's got a bunch of drives. It's got the 2 smart controllers doing all my RAID functionality. And these are just storage units, just dumb storage units, just a bunch of disks. So now I go, whatever, 24 times 4 drives here. I've got, 96 drives here. Okay? And I can carve these up into different LUNs and whatnot. Okay? Now that's the front view. It looks pretty simple. Generally, how do you wire these things up in the back? You have to look at your vendor's documentation, okay? But generally, this is kind of how they wire up. So here's the storage controller in the top, and you have your storage expansion on each of the controllers, right? Generally, they'll go something like this. So we're actually connecting all of these together, okay? Then you could repeat the exact same thing over on the other side, because if you had just one side hooked up, obviously you don't have redundancy, but so we're going to have both sides hooked up for redundancy, okay? And both controllers can access all those disks. Now notice what I did over here. Let me get my bigger marker. Notice what I did over here on the right side. I didn't go like this. I didn't copy it exactly like the other side. I didn't do that. if I did, let's say, forget about the green line. Let's say I got that purple line there. That's what I did. If I lost, for some reason, if this enclosure here died, we wired it up improperly, got a power failure, and it died, then you can't access any of those other storage units. So that would be a problem. So a lot of times you'll see vendors say, okay, no, wire it like this. Start at the bottom and then work your way up. And then the other side, you start from the top and work your way down. So again, if there is a complete storage failure here, right, this controller is wired down here, we're still able to access the last two storage units at the bottom. Okay, so it's just another way of wiring it up. Always check your documentation for your vendor storage. Now, how do we connect our servers to it? So again, depending on what you have. So here I'm showing you the back end of this unit. And again, remember I mentioned you'll generally have host interfaces. Inside your host, you'll have, let's say, these things called host bus adapters. Let's say this is fiber channel, just for argument's sake. These would be fiber channel adapters. I would have two inside each host. Okay, why two? Well, redundancy, right? I got the first one going to the first controller. I got the second one going to the second. So if something should happen to the card or the cable or the controller, I still have redundancy here. Now, in this particular model, this particular picture of this storage, you'll notice there's 4 interfaces, 4 host interfaces on each controller. So in this example, I can just connect my host directly to the storage. This works perfectly fine. There's nothing wrong with this. But if I want to connect more than 4 hosts in this example, then I would need something else. And that's when a switch would come into place, or switches. Again, if this was fiber channel, again, this would be my storage area network. Okay, this whole thing right here is my storage area network. Okay, and then again, you get your we'll say switch 1 and then switch 2. And your first adapter, first switch, second adapter, second switch, and then you wire your controllers into the switches. Now you notice I got controller, I'll call it controller A going to the first switch and controller B going to the second. I could do, now you have to look at your storage, see if it's capable of doing this. I could technically have done something like this as well for performance reliability. Again, check with your vendor, see what they recommend, see what's supported, okay? There's a whole bunch of different ways of doing things. Now, I'm showing you again, so if I want to get past that limit of 4 servers, I would introduce some switches, and now I could have whatever X number of servers, depending on the number of ports I have in my switches, okay? So that's kind of cool. Let me just back the slide up a second. I'm showing you in this example here, I'm showing you 4 host connections on this controller. Even if I go back to the first picture, sorry, I'm showing you 4 host connections. Yours may not have 4, yours might have 2, okay, and that's okay. All right, so it really depends on the model you have. This is just a sample, folks. Okay, these are just kind of samples that I'm showing you, so you have kind of an idea. And like I said, I'll probably do a storage area network 101 video. If for those of you that are interested, just leave comments below. Right. So okay, so this is called a switched multi-host configuration. So now what happens? Let's talk about LUNs. The other thing when we talk about storage is you've got to talk about LUNs. Now I'll just quickly go over this. I'm not going to go too far into it, but right now, if you look in this picture here, if I zoom in, you'll see I've got a bunch of drives, and these drives I group together in what I term as an array. And then from there, you actually create LUNs from here. Okay, LUNs is what your host sees, your ESXi server. So your ESXi server does not see whatever that's 2, 4, 6. Doesn't see 6 individual hard drives. Doesn't see it. It only sees this LUN here. And then let's say this is another array. Maybe I'm doing RAID 5 on this first one. I'm doing RAID 10 on this second one here. This is a 5 terabyte LUN 2. Here's I'm doing RAID 5 again. I'm doing RAID 6 over here, whatever the case may be. So what you're doing, your storage admin is going to connect to the storage subsystem via usually these management ports and configure the storage. They're going to go in and say, okay, these drives, I want it to be part of this array, and I'm going to carve up a LUN or LUNs and I'm going to advertise those to my servers. I'm not going to get too far down the rabbit hole on this, but in this picture here, let's say we're doing shared storage, and this is the advantage of all this. So host 1, 2, 3, and 4, I didn't label those. They could see all 4 of these LUNs here, okay, which is great. And this is what we call shared storage, and we can take advantage of stuff like vSphere's high availability, vSphere vMotion. Again, if you haven't watched those videos, watch those videos. So this is kind of the whole purpose behind this. There's other stuff kind of going on here, but I'll cover some of that in my storage area network 101 class. So again, we've got, again, I've been mentioning fiber channel. I'm more of a fiber channel guy, to be honest with you, because I've worked with, I even have some here from back in the old days. But this could be an iSCSI solution as well. iSCSI solution. These could be iSCSI HBAs. This could be Ethernet cables going into Ethernet ports on your controllers. Or even back here, again, this could be an Ethernet switches, and these could be iSCSI HBAs. Or you could use software iSCSI. Okay? So I know I've been mentioning fiber channel, but you could translate this into iSCSI as well, or fiber channel. Okay? So just keep that in the back of your mind. So if you know one, you kind of know the other. Okay? Okay, what do we watch for? Okay, for those of you that kind of skipped the first part, welcome to what to watch for. So some of the counters, I'm going to use NSX top for this, but you can use the performance monitor as well. Some of the counters you want to watch for is latency. Latency is bad, right? Latency means I'm waiting for something to happen. I issued a command, I'm waiting for the response, and it's taken too long. So latency is our enemy, okay? Now, when we talk about latency, there are certain counters we can look for. So first of all, we have the guest average latency, we have the device average latency, and we have the kernel average latency. So, and I'll give you an example of that when I go into the next slide. But the guest is, this is the latency your VM sees. So whatever operating system's inside that VM, that's the latency it sees. So it sees that. The device, this is basically your physical device. What's the latency there? And then the kernel, this is how much time your instructions spent inside VM kernel. Usually this one is low, but there's situations where it could be high. And then we have the device. Now they're showing you some numbers here. 20, I think, maybe a bit on the high side, to be honest with you. I would really start questioning this. I'm not going to panic, but if I see it around 10, I'm going to, that looks interesting. I should probably look into it a little bit more, especially if you have VMs that are complaining. If you go, oh, my VM's complaining about performance. Like, for example, somebody saying everything is slow, right? And that's the other thing I kind of hate. People say, oh, this is slow. Well, what do you mean it's slow? Like, tell me what you're doing, or like, what are you doing at that point? I've had a lot of people say, oh, it's slow. Well, tell me, what are you doing? What are you doing at this point? Oh, I'm doing a query, or a database query, or I'm saving this, or I'm copying that, or whatever the case may be. There's got to be something. I'm logging in, right? You must be doing something and say, oh, okay, it's slow. Now, is that slowness repeatable? Okay, do you consistently see it slow? Then that helps you do a little bit of troubleshooting. If it's intermittently slow, those are those can be fun things to track down. But latency is one of the big ones here. Again, I would, if you're hitting 20 and 30, that's bad. You got triple digits there, that's real bad. Okay, I would start questioning it at 10. I'd say, I might want to keep an eye on this. Queued, anything over 0, right? So if you see 1, that's bad. That means my kernel queues are maxed out, and I'm starting to wait now, and I'll explain that in a couple of slides. Disk aborts definitely ain't good. We aborted some commands because something's wrong. So anything above 0 is bad. That's like dropping packets. Think of it like that, right? Anything above 0, right? Same thing with disk resets. The number of atomic test and set number failures. Again, anytime you're doing resets and failures and aborts, those aren't good. And this is the number of SCSI reservation conflicts. They're saying here 20. I'll be honest with you, if this is high, you're going to see some latency issues as well. So to me, the big one I'm going to look at is usually these latencies. Okay, that's really what it boils down to. Now, one thing I want to point out here, I pointed out 3 latencies: the guest, the device, and the kernel. The guest latency is equal to the device latency plus the kernel latency. So remember, the guess is effectively, what do I see? Well, I don't care who's slow. Is it the kernel, your ESXi server that's slow, or is it the storage that's slow? I don't care. Ultimately, I, the guest, see it as slow. All right, queues. Now, what are queues? Queues are basically, now depending on your host bus adapter, you got a fiber channel, iSCSI, HBA, that type of thing. They'll have a number of commands that they can execute simultaneously, right? Like a fiber channel HBA may be able to execute, let's say, 2,000 commands simultaneously. In other words, I can fire 2,000 commands down to your storage without having to hold on to stuff, right? Now, each, you have your device driver, which is like your adapter. It's going to have queues, and then the kernel is going to have queues. So the device driver, think of that as your physical one. Each LUN also gets its own set of queues as well, okay, based on the device driver. So you'll have, think of the kernel devices or the kernel queues as an overflow. That's one way to kind of look at it. Now, for example, if I had a device queue of, let's say, 64, right, that means I could fire 64 instructions down that pipe at the same time. Go ahead and do all that stuff for me, right? If I had a device queue of 1, that means I send 1 instruction at a time. Boop, boop, boom, okay? So more sounds better, right? Well, more can be better, but it also can be bad too, right? For example, if your adapter, your host bus adapter, can execute, let's say, 2,000 active commands, and let's say you got 40 LUNs going through that one, let's just assume that one adapter's going, you know, you got 40 LUNs going through that one adapter. You probably have more than one, but anyways, you got 40 LUNs, and if you got 64 queues, or a queue depth of 64 on the adapter, 40 times 64 is like 2,500 roughly. That's more than that 2,000. So at that point, we're going to start queuing stuff. We won't be able to send those other ones out. We got to wait till that first batch finishes. So increasing the queue size may not be a good thing depending on your environment. And I'll show you a couple of things here on that, okay? So now this picture here illustrates the guest average latency. So here's your VM at the top, okay? This guest average latency, it's a combination of the kernel latency and the device latency. The device latency being down here in the physical part, the device driver, the card, the physical disk, okay? Most of the times this issue is down here, to be honest with you, okay? Most of the times. Now, notice over here, the kernel latency also has this queue average time. Remember I said the device, so here's our device queues over here, and I said the kernel has its own queues as well, and think of it as like an overflow or a backup. Once we start filling up, let me clear all this. Once we start filling up the device, and then we start filling up the kernel, at that point, this is where the queue average time comes in. How long are we waiting inside kernel? This number should be like 0. If this is a high number, your kernel average latency is going to be high, and then therefore your guest average latency is going to be high as well. So we really want to see these numbers being very, very low. Then generally they should be. If there's a problem, most of the time it's down in the physical. I'll give you an example of this as well. So these two are related to each other, okay? Now, how do we fix this? I'm going to do a demo on this, but generally, how can we fix this? There's no one, you know, I'm going to press this button, everything's going to get fixed. There's a lot of different technologies, and they all have their trade-offs, the pluses and minuses. Personally, I like fiber channel. That's just me. The nice thing I like about fiber channel, if I go back on my slides here, I don't want to go like that. What I kind of like with fiber channel, let's assume this is a fiber channel storage. What I like about it is it's got a separate physical network, completely separate from your Ethernet network. iSCSI, on the other hand, a lot of people will, not a lot, I shouldn't say a lot of people, some people will say, oh, okay, we've got an Ethernet network already set up, let's put iSCSI in there and we'll put on a different VLAN. Well, the VLAN, okay, great, that isolates the iSCSI traffic from all your other stuff, but it's still sharing the physical network, right? So performance can be impacted by that. Whereas fiber channel, I kind of like this. It's right off the bat, I know, okay, these are fiber channel host bus adapters, okay? And I may have Ethernet cards inside this host, and they're completely separate from each other. So that's kind of one of the reasons why I'm a big fan of fiber channel. But again, you know, technology does make a difference. RAID level matters, okay? RAID 5 and RAID 6 are generally really poor for write environments. So if you've got an environment that's doing very heavy on writes and performance is a key concern, you want to stay away from RAID 5 and RAID 6. Because RAID 5 and RAID 6 have those parity and double parities it has to calculate, and that takes time, okay? So that matters. If it's a LUN that's going to be used just for reading, we're streaming stuff from it, we're just reading, then RAID 5, RAID 6, there's nothing wrong with that. Cache size does matter. Generally, you'll see people say the bigger the cache, the better. And for the most part, that's correct. The technology is whether it's write back or write through. What is that? Let's say I got my SCSI controller here. SCSI controller. And I've got, let's say, a bunch of disks sitting off of it. I'm just going to draw one disk, right? Then I've got, let's say, my cache right here. The cache. All right. Write back means when a command comes in, it hits the cache, it's written in the cache, then the acknowledgement sent back to your operating system saying, yes, it's been written to disk. It hasn't been written to disk, it's been written to cache. That's write back. When the controller gets a chance, it writes it out to the disk. So the cache is generally a lot faster than disk, generally speaking, okay? And we can debate this with NVMe and all that stuff, but it doesn't really matter, okay? A lot of times, the bad thing about this is if your power goes out on your server and your contents of cache is usually lost. Now, a lot of times these controllers will have a battery backup, little plus and minus, little battery on there. So if the server dies, the power went out, it should have UPSs by the way, but let's say whatever the server dies, the next time it come up, the contents of cache is maintained by that battery, and it says, oh, I got contents in my cache, I better write it to the disk before we boot the operating system, okay? Write through, basically, actually no, I don't want to clear that. I'll use a different color. Write through is I'm basically disabling the cache, I'm going to write straight to disk, okay? That's generally speaking slower, depending on the disk, obviously, right? Because we write it to disk, then we got to wait for the acknowledgement to come back. Disks are usually slow, right? So write back or write through, what are you doing? Now, there are situations, I've run into this many times over the many years. Actually, sorry, I shouldn't say I ran into many times. There are times when write through will give you better performance than write back. If you're in, and this is very rare, if you're in a situation where you're doing a lot of large sequential writes to a disk or storage, large sequential writes, what happens with write back is you're writing to cache and we acknowledge. We write to cache and we're going to fill the cache up eventually, okay? Then at that point, we have the extra task of maintaining the cache and emptying it, writing it to disk. That extra little overhead makes my performance worse as if I just wrote it straight to disk. So there are situations, if you're extremely doing lots of heavy writes, sequential writes, your cache fills up. The bigger the cache, the worse your performance will be in that situations. I run into it before, very rare situations, but it can happen. So you got to watch what's the behavior of my workload. Block sizes matter. Bigger block sizes usually transfer stuff much faster, right? The number of disks per LUN. In that picture, I showed you I showed you the storage, right? When I went this picture here, I said, okay, these drives here are going to make up this LUN. It's RAID 5, and there's what 2, 4, 6 drives there. A general rule of thumb: the more drives, the better your performance. Okay, a general rule of thumb at IBM that we used to use: if you're doing 50% reads and 50% writes, if you double the number of disks in your array, so if I went from, this is 6 drives over here, if I went from 6 to 12, I would increase my performance by about 50%. That was kind of a general rule of thumb that we went with, right? So by adding more drives to your array, you can actually increase performance. One of the problems with why storage a lot of times is usually the culprit in performance is because When you think about processors, you're thinking fast. You're thinking speed. When you think about memory, you're thinking, I want to put in tons of memory. You're thinking about speed. And then the network cards, you're thinking, I want that 25 gig, 40 gig, 100 gig card. You're thinking performance. A lot of times, now this has kind of changed over the last few years because of solid state drives and NVMe. A lot of times people, when they talk about storage, they think capacity first and then performance second. They'll say, oh yeah, 5 terabytes, that's good. I could put all that on one disk. Now imagine if you've got 100 users hitting that one disk. That disk is going to melt, right? So, and I've run into that before where customers basically was thinking capacity and not performance. So the number of disks in the array can greatly improve your performance. The more disks, generally the better. Read-write ratios. Am I doing lots of reads or am I doing lots of writes? Again, you need to know that. And I'll show you how we can figure that out, because if you're doing lots of writes, your RAID level is going to come into play here. Am I doing sequential reads or sequential writes? Okay, so you need to understand the behavior and not it's slow. You understand what the behavior is. Now, how can we fix a lot of this stuff, right? Well, one way to do it is vMotion or storage vMotion. Oh, you might be asking why vMotion. Storage vMotion. Oh, I've got too many VMs on this LUN, this data store, and they're all pounding the data store. Let's move a couple of VMs off to a different data store, that's storage vMotion, and then this way we can alleviate some of the pressure on the storage or on those LUNs. That kind of makes sense. Hopefully those LUNs are backed by different disks and not the same ones, right? Or else that wouldn't make sense, okay? And what do I mean by that is I could do something like this. I don't recommend it. Let's say these are my physical disks. Let's say these are my physical disks, right? Hard drives, hard drives, hard drives. I can say, okay, I'm going to make an array out of that. So an array is just a group of drives. Okay. Again, your storage terminology, depending on your vendors, might be different. I'm going back to my IBM stuff. So I made an array there. I can then go in there and carve this up. I'll say, I'm going to make a LUN here. That'll be LUN 1, and that'll be RAID 5. Okay. Then I'll do another LUN. I'll do a LUN 2, whatever, RAID. I'll say RAID 5 again, whatever. Okay. I don't care about the RAID level. I could do another one. See how I got two different LUNs 1 and 2, going across the same physical disk. Your ESX server would see two LUNs here, whatever sizes they are. So if you move VMs from one LUN to another, you're making no difference here. They're hitting the same physical disk. So you can do this on a lot of storage subsystems. I'd highly advise staying away from it. vMotion, why would vMotion solve a storage problem? Remember, we got the queue, the card, your device driver. Again, maybe on that server, the queue is getting filled up. So moving it to a different server with a different adapter and its own queue, that may alleviate problems. Softwareized SCSI NFS uses CPU resources on host. Again, that's that technology that we talked about, right? So you got to be aware about that. Your path policies as well. You can actually go in and specify, do I want a fixed policy, most recently used, or round robin? This is usually the behavior of the storage itself. And it's a capability, and some might, I should put custom here. Vendors have the capability to have their own custom type of pathing policies. So you can go into your data store and change the pathing policies. Again, I highly recommend against it, okay? Unless you know exactly what you're doing and the vendor agrees with you or suggests it. Most of the times when you pop in a storage subsystem, your ESXi host will detect that as long as it's on the compatibility list and say, oh, I'm going to use a fixed policy, or else I'm going to use a most recently used. Now, what's the difference between these policies? Okay, let's just quickly draw a couple of servers here. Server 1, server 2. Let's say I got some switches here. Switch 1, switch 2. This could be iSCSI, fiber channel, I don't care. Here's my host bus adapters inside the servers. First card, first switch, second card, second switch. And then here's my storage subsystem. Here's my controllers. I'll say A and controller B. First controller, first switch, second controller. I'm just going to draw just the two paths, that's it. Let's say I've got some LUNs here. LUN 1, LUN 2, LUN 3, LUN 4. Now, let's just assume both servers can see all four of these LUNs. That's great. Now, a fixed policy means this LUN 1 is owned by controller A, and we access it, let's say server 1 here accesses that via this path. That's a fixed policy. If something should happen to this path, or the controller or switch, this LUN here, LUN 1, would fail over to, let's say, controller B. Same thing with LUN 2, but okay, whatever. So it would fail over to controller B. So now we can access it over the other path. If I fix the problem, let's say over here on the left, I fixed the problem, it could fail back. Okay, it would automatically, because it says fixed, I always want to access it from that. Okay, if it was most recently used, what would happen is the same kind of example here. If there was a failure when the path or card or switch or whatever, it would fail over to B. And let's say you fixed the issue, you fixed the problem. Okay, you fix the problem. It does not fail back automatically. It stays on B until you go into the storage software and say, okay, move it over. So most recently used. And it's going to depend on your storage subsystem, which one it uses. A lot of the stuff I did at IBM was most recently used. Okay? Okay, great. What's round robin? If your storage subsystem has this capability, let me redraw this because it got messy real fast. So here's my servers again, server 1, server 2, the adapters, the host bus adapters, first card, first switch, second card, second, first card, first switch, second card, second. Here's my storage, here's the controller A and controller B. Let's hook it. Just going to draw one wire to it, right? If your storage supports something like this, LUN 1. I'm just going to draw one LUN. Both can access that. Then at that point, I could take either path. And round robin, if your storage subsystem supports this capability, it generally, now you have to look at the default, generally it would be 1,000 IOs. So it's going to fire 1,000 commands down this path. And then the next 1,000, it fires down this path, right? So it's almost, I don't want to use the word load balancing. It's almost doing that, right? You could change that 1,000 to a smaller number, which probably makes a little bit more sense. You know, maybe 2 commands down the one path, 2 the other. This way, you're not just blasting a whole bunch down one path. And if that's the bottleneck, well, it's not going to help out. So now you might be tempted. I'm going to go in and change these values, right? I actually had a customer that did that once back in my IBM days, and they actually had an IBM storage subsystem, which I was very familiar with. I taught it on for many years. And they changed it from most recently used, that was the default policy, I knew that, to a fixed policy. Don't ask me why they did it, but they did it. So they went into server 1 and changed it to fixed, server 2 changed it to fixed, and whatever, they changed it all to fixed, or whatever their reason was. Then they started adding in more servers, and they forgot to change the behavior on that. So some of the servers were accessing it via fixed, some of them were accessing it via most recently used. And all kinds of bizarre stuff was happening. LUDs were disappearing on one host, reappearing, disappearing. It was really crazy. And I remember I was teaching a class, actually a VMware class, and they were talking to me about this. It was a troubleshooting class, actually. And we started talking about this. And most times I don't look at customers' equipment, especially in a classroom environment. I don't like that. I don't like to touch the keyboards on this stuff. So I said, let's look. And I looked and I noticed it was a fixed policy. And I said, somebody changed it. They said, no, they didn't. And I go, yes, they did. I know, because my classroom had that exact same storage. And I said, look at the policy. It's most recently used. So they went and changed it back to the default, and that solved their problem. So what am I saying here? Don't just blindly go in and start changing the policies on this, okay? Look at what's supported by the storage. Talk to the vendor. If the vendor's recommending a change, then I would ask the vendor, why don't you make that the default then? Okay? So watch out for that. So that's what these pathing policies are. So round robin is one that can actually improve your performance, right? They actually all can, because again, it comes down to the storage. You can say, okay, if you got too many LUNs sitting behind one of the controllers, maybe you need to spread that out manually, okay? So that would be like what the storage administrator would do. So a couple ways to fix this. It was fairly high level. Let's take a look at some of these counters now, okay? So stick around. By the way, if you stuck around this long, hit that thumbs up. And if you haven't subscribed to the channel, hey, support the channel by subscribing. I'd really appreciate it. Thanks. Demo time. Okay, so we're back. It's demo time. So let me just show you a couple of things. Just a typical vSphere environment I got set up in my lab environment. It's not the quickest. I got 2 Windows VMs running. They're both running on host 1. You'll notice if I click on Win 1 here, it basically has connection. Where are we here? You'll see over here on the far right, it's got storage on the vSAN. So the VM's located on the vSAN data store, but it's also got a disk on the ESXi01 local. So I got a local disk on this. I don't have fiber channel or anything like that, you know, to show all that, right? If I click on host 1 here, so both VMs are going to run on host 1. When I look at host 1, I go to Figure, I go to Storage Adapters. You'll see I got an iSCSI adapter here, so I got an iSCSI LUN. There's a VMHBA1, a VMHBA0. This one here looks like it's just for like CD-ROM and stuff, but the VMHBA1 is like it's SCSI controller that's built in. If I look at storage devices, again, you'll see VMHBA0 has a couple of devices. This is a vSAN data store, so you'll actually see that there's a few things set up. And then I also have this one here. This is not part, this disk here, it's 100 gig in size. It's not part of the vSAN data store. Notice it's basically the ESXi local. So I formatted that with the VMFS file system. The other disks are part of my vSAN data store, okay? And there's my iSCSI, but we don't care about that for this demo anyways. All right, so that is VMHB 0, controller 0, target 4, LUN 0, okay? So there we go. Let me go into my Windows machine here. I got Windows 1 here. I got a tool called IO meter or iometer or whatever you want to call it, right? It's right here, IO meter. And I've got it set up with 4 workers. I got 4 virtual CPUs in this VM, and they're all going to hit the E drive. Now, if you're ever playing with IO meter, this was a tool developed many, many years ago by Intel. It's now open source. Don't run this on production disks. What this does, it'll actually fills up the disk with a file, right? So I created a 1 gig disk for these VMs, basically, right? So it's running it against that E disk over here, right? And then go access specifications. There's some default behaviors here. You can say I want 50% reads, 50% writes. I want this size block, so on. You can get really fancy with this. I just went in and I created one here. And if I just show you, like I created, I said I want to do a 10 meg access. So under here, transfer size 10 meg. I want percent of access specification. So give me 100%. I want to hammer this thing. I want to do 100% writes. Forget about reads. I want to do sequential writes. I really want to hammer the bugger out of it, right? And that's basically it. So I'm saying use that. So I'm just going to hit this, and it's going to start hammering the disk. And I say okay. So at that point, it's starting to hammer the disk. Win 1 is hammering the disk. Win 2 is not doing anything. Let's go into my host. I've already got putty running over here. If I've puttied into my ESXi01, I'm just going to type in ESX top. And again, we get the CPU screen. I've already talked about that, my CPU one, so let's forget about it. Let's go to D for devices, or D for, yeah, I'll call it D for devices. And you see over here is my adapters, VMHB0, VMHB1, VMHB64, and 65 is my iSCSI. You'll notice VMHB0 is getting hammered, okay? It shows me very low on the reads per second, a lot on the writes. You see my megabytes reads, and you see my megabytes written. So this is a way of telling, oh, I'm doing a lot more writes than reads, okay? You see my device average latency, my kernel average latency, and my guest latency. So the guest is, again, what the VM sees. So that's 3, it's pretty low, okay? So that's okay, it's hammering that. There's my device there, right? Now, if I go to, I want to look at the actual disks, I type in U, and it shows me the actual disks here. So there's VMHB 0, target 0, LUN 0, target 1, LUN, so on and so forth. Here's the one I care about. That's the one where that VM is located on. Okay, target 4. You see the disk queue length is 256. So that's how many instructions it can fire out simultaneously, right? You see actively on the fly at 16. This is updating, like, let's say every 2 seconds. I'll hit S, and then number 2 is update every 2 seconds. You'll see queued. I'll explain that in a minute. You see how much of my queues are being, percentage of my queues being used. It's really nothing. See the commands per second. You see the reads and writes per second. The megabytes read and the megabytes written. Device average latency, kernel average latency, and guest average latency. So we see these things I just talked about. I get nothing for me to freak out. Looks like the VM's getting its stuff. A little low latency. That's fine. Let's do something here. Notice the disk queue length. Okay, the device queue length. That's how many queues this device has, right? Let's start up another. We go to Win2, and I'm going to start hammering the disk from Win2 now. Whoops. I'll say OK. And now at this point here, I got 2 VMs hammering that disk. Let's go back into ESX top. And one of the things you'll notice right off the bat, look at the latency over here on the far right. The guest average latency, it's high now, more than 10, right? 10, I start worrying, right? 20, there's a problem, okay? That's obviously a problem there, okay? We're at 65. You see the guest is seeing this high latency. Let me just set this. Actually, no, I'll leave it alone. The high latency in the kernel and low latency in the device. So which is kind of strange, because most of the times you see the latency in the real world, you'd see the low latency in the kernel, but high latency in the device if the disk subsystem was configured incorrectly, or if it was getting hammered by everybody else, right? So I wonder why it's the kernel that's causing this issue, right? Now we'll see in a minute. You see all the other stats, which I don't care about right now. Notice my device queue length wasn't at 256, and it just dropped to 32. Now active and queued, okay, and percent used. Percent used is how much of my queue and my kernel am I using? Notice it's fluctuating from 9% to 100%. Now, again, this is kind of just taking a quick snapshot. So at that time, it might have just dropped a bit, right? Then all of a sudden it's up again, right? So these numbers here, these are bad. Sorry, not that one. These ones, this is bad. See the number active? It says it's 32. So I've got 32 instructions going out right now, and my queue length is only 32. So I've filled my queue. So that means we've got to wait. So this is why you'll see when this hits 32, generally you see it's 32, then this is 20. There's 20 more waiting for that 32 to get cleared. And then you'll see this 100% get used, this go up to 100. So these two having, this is showing me how much time it's spending inside VM kernel and the queues that are being used up in VM kernel. But why did this drop to 32? What was going on there? Let me show you something. I got another putty session running here. Apologize for the ugly color. Let's type in ESX CLI storage. Can I spell today? No, I can't. Storage core list. No, it's not core list. It's core device list. These are all the devices. There's my iSCSI. There's all my devices that are here. Here's the VMHV 0, target 0, LUN 0. Here's another one, target 1, LUN 0. Target 2, LUN 0. Where's that target 4? I'm scrolling up with my little mouse here. There's target 4 right at the very top. Okay, that's the one that we're hammering, okay? Maybe I want to look at just that one alone. Let me copy that. So I just copied it. Let me run this command device list -d device paste. So instead of show me all, just show me that one. Okay. So there's the one. Okay. And then over here you see the device queue length. Device max queue length is 256. Okay. All right. We've seen that. What's this? Number of outstanding IOs when competing worlds. 32. You see how the queue length dropped to 32? Because now I got VMs competing with each other on this, right? So it drops it to 32, okay? Because we don't want one machine kind of monopolizing everything. Let me show you something. Let me show you basically changing that setting. So let's go into, again, we still see it over here. It's still listed 32, and this is 100% of our queues are being used up. Okay, so let's go into here. Storage device set -device. Oh shoot, I should have copied it. Let me copy that. There's the device. I don't want to copy all that. There's the device right there. So I just copy it. So dash D, device, dash O. I don't know what the O is. Oh, whatever. And then the value. I'm going to set it to 128. Let's run this thing again. Notice here, again, max queue depth, 256, but I now just change it to 128 when there's competing worlds. Let's go back to here. Notice now in ESX top, it's now 128. And we see active, notice again, if I give it a few seconds here, this actually dropped a little bit. Remember it was like 65 and stuff? It's actually dropped to 33 now. So by changing that, I'm allowing more commands to go out. Don't queue them up, fire them out, right? So that's why you see this number over here. It was like 60 something before it. We saw 70. It's dropped down. Let's try something different. Let's do that. I don't recommend doing this in production, by the way, okay? Always, if you're going to make changes here, always talk to whatever storage vendor you're dealing with, see what they recommend, okay? But I'm just showing you kind of how these things look or operate. Let's change this. I'm going to set it to the max. So now I've set it. I said, where are you? Number outstanding IOs with competing worlds, 256, right? If I go back to here, see it says 256. I'll give it a few seconds here. You have to let it settle down a bit. Actually it's actually dropped a little bit in latency. We'll give it a few seconds. I'll give it a few seconds to settle down. Let me just pause this. We'll check it in a minute. Okay, so I let it settle for a bit. We still see we have a high queue time over here inside our kernel. Our latency seems to be better. So you see how that kind of helped out, because before it was pretty consistent. It was high like 60s, 70s and stuff like that. So it actually lowered the number, but we're still seeing the problems in the kernel here, right? And I'm actually hammering the machine, right? So how do I know what VMs are doing this? So I can hit the letter V, and it shows me there's Win1 and Win2, and it shows me the commands, the reads per second, the writes per second, the megabytes read and the megabytes written. So you actually see that, and you can actually see a little bit of the latency on the reads and the writes. So the latency is pretty high over there, right? So this is one way to identify which VMs are hammering a disk. Now, unfortunately, I can't narrow it down, or I don't know a way to narrow it down to which disk, not within here. I'd have to go into perfmon, right? So if I go into my performance monitor here, if I go to ESX, let's go into monitor performance. I can go advanced, and then under here I can say I don't want to look at CPU. I want to look at data store, right? So you're actually seeing you're actually seeing over here the data store that's actually going to start getting hammered, right? So let me look at the shared one. That's the one I want to see. We don't care about those other ones. So I'm actually seeing that one's getting hammered. Now that I know it's the two VMs, let's click on the VMs here. Win1. Let's go into monitor. Let's go into monitor and then advanced. And then you actually see over here they're showing CPU. So let's go into disk, and you'll actually see over here which disk is this. You see the read rate, write rate, and then the usage. The win is like the overall, okay? You see the local here, it says win and local. This local here is actually the second disk, and you actually see the write rate on this thing, okay? So you can kind of tell from here which disk is really hammering it, whereas this one here, let's get rid of it, sorry. Is it this one? That's the, local disk, and it shows me right here. There we go. Target 40. There's that one that we're talking about that's getting hammered. Okay, so kind of a way to do it within here, but with ESX top you can again narrow down what VMs causing the problems. Now what can I do to fix this? This is just one disk. It's just getting hammered. It's in a virtual nested environment. So what can I possibly do to fix this? This is in the real world environment, right? This was in a production environment. I could actually go in and maybe say, oh, okay, let me just go back to, do I want to go to device? No, let's go to disk over here. So we see here again, the latency has dropped a bit once I made that change. Remember, it was consistently like 60, 70. So it did drop when I made that change here. Now, I would not advise, like I said, I wouldn't advise you just doing that change in a production environment. If you're seeing an issue, got high latency, again, over here, my device, and then my kernel, and then my guest over here. So the guest is seeing high latency, right? What I would do is figure out what VMs are doing it. We already know it was Win 2 and Win 1, and they're hammering the same LUN or same disk. Can I put that onto a different data store? Maybe I can move one of them over to a different data store. Maybe this data store that they're hammering, that LUN that they're hammering, doesn't have enough disks backing it up to support the throughput that this thing needs. So all those things that we talked about, right? So those are the things you got to keep in the back of your mind. So move the VMs off. Maybe put it on a different server hitting the same LUN. This is a local disk, so I can't do that. But so keep that in the back of your mind. One of the other things, I was actually doing this, and I kind of broke one of my own rules, is see, I have an iSCSI LUN. I can start hitting that, but that's running across the same network as I do my management, right? In this environment, and if I start hammering the iSCSI, it's also going to hammer my management of my ESXi host, so it renders the results kind of useless because I can't monitor it, right? So I just wanted to point that out. But again, that's storage performance for you folks. Leave comments and questions down below. I hope you enjoyed it. Hit the thumbs up if you found this entertaining or useful. Please support the channel by subscribing. Really appreciate that. And for those of you that have already subscribed, 2 thumbs up to you folks. Thanks very much for supporting the channel. Have a great day. Bye now.